Hey everyone, hope you guys are doing okay. Hey, finally got some just kind of FYI, some added attributes to my office here. It's kind of a dark setting. That's how I have my office, just kind of dark tones. I guess they call it moody, but anyway, um, it suits me. But got some new lighting, things like that. So kind of moving up in the world. But anyway, just thought I'd share that with you guys. So I appreciate um, all you guys subscribing. Of course, share a like, and make sure you hit that subscribe button and get your notifications. You know the drill, I guess, by now, right? So anyway, I thought I'd do a quick little tutorial on the impact of relationships. And I'm not talking personal relationships, even though we all need help with those, right? But anyway, the impact of relationships in Power BI, resulting, on the measures that you create. Especially in particular if you have bidirectional, many to many relationships that occur in your data model. Not really the best ideal situation is to have something like that. And so hopefully I can explain without going into a lot of detail. I have an example that I could show you guys, and hopefully that will help. In the past, I get quite a few friends and colleagues, people I've met in my life that all in the Power BI data realm, come up with real case scenarios with their reports at work, and a lot of them, they just come to me and say, I can't get the right values, or maybe some of the values that I'm showing, if I just drop it in the table, I think it looks okay. I'm not sure if it is okay or if it's correct, but you know, but I've got a bidirectional many to many, and any book that you read, Greg Deckler's books are a good example. Some others I can't think of off the top of my head. I've got them behind me on my shelf, but anyway, it's you kind of wonder why it's there, why Power BI puts bidirectional relationships in there if they are frowned upon. But whatever the case may be, it's there, but it will give you some incorrect values, especially as you have more detailed data sets that you come across. So the bigger the data set is, and you have bidirectional relationships, it is just not going to work out well in the end. So also, I've wrote a newsletter about this on my Substack. For my paid subscribers, I offer the file there as well. But I wanted to do a quick walkthrough and share with you guys as well, because we're all visual, and it's always good to kind of see how this works out, and why it why in this case bidirectional wouldn't work. So if we go on, I will bring up my Power BI example. So this is what we're going to talk about. This is all fictional data. Nothing. It's just got generic stuff in there. Employees. This example, we're using courses, dates that it was completed by the employee, if they passed, if it expired, if the class canceled. Just simple, really straightforward data set. Nothing really fancy about it. So as we go through this, again, why does this type of relationship matter in Power BI, or any relationships? And we know relationships in Power BI They define how tables interact with one another. While it might seem straightforward to connect tables, the type and direction of relationships in your data model profoundly influence your measures, and we'll see that. It may look okay, but it really isn't. Um, so again, we're going to be talking about many-to-many relationships and using a bridge table to solve that issue. So, um, so let me click on here and I'll show you. So we have two tables right here, and I've got if I'm looking up, it's because I've got a second monitor here. So, but anyway, so you have your main table where it's just summarizing information related to each course in this example, including some system identifiers. And then you have what's called the train history. It's just short for training history, and it has the detailed records of the training courses completed by the individuals. So, and you can see here, obviously, you see the stars for each table, and it's a bidirectional many to many. And you can see that, and it already gives you a flag. Hey, this relationship has some cardinality. Um, really, you're going to expect some some results that might look okay, but in reality they're not. So how to avoid that in Power BI? You use what is called a bridge table, and it enables a one-directional, one-to-many relationship structure. And we'll go through that here in a second. So wanted to really touch on the pros and cons. Like I said in the beginning, some people say, "Hey, bidirectional many to many. What the heck? What's wrong with that?" So the pros are, you know, it's easy to set up with few tables. You just drag and drop. It's fast to implement, especially when tables share a common column. Like in this case, it's component ID for each course. So the cons, like I had, mentioned, the likelihood. One of the cons is likelihood that you're going to get duplicated or inflated values in your calculations. You're going to have unrestricted filter flows across the table, which lead to, unintentionally, of course, aggregations, especially if there's duplicated entries in both tables. Like an example would be if a student, one student can be enrolled in multiple courses in this case. Like when you go to college, you're enrolled in math and history and English and then your electives, but you're one person but has multiple classes. And they all have different identifiers. So that's where things kind of get buggy with bidirectional many to many. Um, so let me see here. So without trying to repeat a lot, but I wanted to get the concept. I don't know why that's on there. The concept across to you guys. With a bidirectional many to many, Power BI counts all instances in this scenario, all instances of all completed courses, and that's what we're looking at in this case are completed courses across both tables. So Power BI really doesn't know, you know, what to grab, what information to grab. Certain completion courses might be counted multiple times, and then this leads to higher than accurate, um, you know, uh, for example, like a completion rate. You want to measure, across the number of students, um, what's the completion rate? Are they, is it a higher percentage or a low percentage? So let me show you one of my measures that we're going to be showing. So I've broken down where you have a completion rate, um, for a bidirectional, and then I have an example for the bridge table. So what we're doing here is just really, let me move this back over for you. Um, Bring that back up again. So completion rate, bidirectional, divide, you calculate, open that up by counting the rows in your train history. And I've got a second one for this example. So I broke it down to two different sets of tables. So I have a main and then a main with a number two, and then a train history, and then a train history number two. So the number two would be for the bidirectional example. So we have this measure, count rows, train history, completion status equals the course pass. And then you just count the rows again through your train history. So if we go back to the bidirectional, that measure is the one I just showed you over here, the completion rate, and it gives us a 56.1% completion rate. And you're thinking, hey, that's cool. Seems right. Everything looks okay. I've dropped all my information in this table. Employee 12, has that a completion rate. Employee 13, 11, not doing so great. Employee 10. So we'll stick with employee 12. They seem to have for this case, a higher completion rate. So again, you're looking at that, you're thinking, hey, that looks pretty good to me. So, but it's not, because it is, like I said, counting for duplicates. It's counting all of that. So it's not real, because it's going back and forth. You have that bidirectional relationship where, you are going back and forth, table to table, duplicate values, counting over and over again. So enough of that, right? You're thinking, okay, Paul, I've heard enough. I get it. So to avoid that, and let's see this example now. You set up a bridge table. And a bridge table is really, you want a common column that's in both of your tables. And in this case, it's your component ID. So create your bridge table. You're bridging, you're creating that literally like a bridge where you're walking across from one side to the other, and the bridge is joining, two pieces of information. Just like in real life, when you cross a bridge, you're going from one side to the other and back, but that bridge holds that common feature. And I think I posted something on LinkedIn. I used a metaphor for a bridge to kind of maybe help people out, try to understand the importance of a bridge table to avoid it avoids and helps you with your bidirectional relationship. So we've got this bridge table. You can see it has component ID. You have a one-to-many with your train history, and then your one-to-many from the bridge table to your main fact table there. So if you remember, here's your bidirectional. You calculate, count rows, and okay, that's great. Know how to do that. But what the bridge table does, it ensures that all filtering flows through the bridge table, and you avoid, again, that direct many-to-many relationship between those two tables. Gives you accurate aggregations. It controls the filter direction, and you can see that. You're one to many. So how do you get information from here related to this by going through the bridge table? So let's go back to our example, and I've got another tab. So remember, bidirectional, we have 56.1%. When we use the bridge table, and I'll show you the measure, we have the same table set up, but now we have 52%. And you're thinking, okay, why is there a difference? So the difference between the two that helps in Power BI using a bridge table, and I'll show you the measure, is the fact that that measure, like I said, you have that. So again, you see with this measure, same measure, but you are using the bridge table instead. And let me show you. So you get 52%. So I hope this helps you guys, better understand the difference between bidirectional many-to-many and the problems that will cause in your report. You may think again that you have good values, but looking back, it's really based on how your relationships are set up. So the key takeaways with this bridge table provides a cleaner calculation, air quotes around cleaner calculation, by eliminating the redundancy, the back and forth. Also with this, when you have your data model set up perfect like this using the bridge table, your measures work a lot better. It just you'll just So I hope this helped. I hope you got some benefit from it. I hope it made sense to you. Go back, rewind, pause. Make sure it's really, the concept of it. So wrapping up again, so to build effective relationships in Power BI isn't just about, connecting your tables. Using the bridge table to avoid your bidirectional many-to-many helps control your filter flow and ensures reliable calculations with your report. And that's essential, especially when you're creating, KPIs for your manager, analyzing metrics or any other form. Just keep in mind the right relationship structure can make all the difference. I think I read somewhere, or maybe even Brian Julius pointed this out, 80% of your Power BI report development is data modeling, data cleaning, setting up your model, especially the relationships, making sure you have that one-to-many and your flow direction is one way. So by choosing bridge tables over bidirectional many-to-many relationships, you'll bring greater accuracy to your reports and offer more, actionable insights. So again, hope that helped. Thanks for watching. Appreciate it. Drop me a comment. Just let me know. So until next time, I will see y'all later, and happy data modeling.